Hey everyone, it's Justin again, and in this video we'll be introducing the basic skill needed for algebra, solving equations. So make sure you've watched our video on variables because we're going to be using them a lot from now on. Here we've got a scale. The right side has 8 pounds on it, while the left side has 3 pounds, and then an unknown weight, labeled with the variable x. Our goal is to figure out what the x block weighs. An important thing to note here is that the scale is balanced. Both sides weigh the same amount. So the unknown weight, x, plus 3 more pounds, is the same thing as 8 pounds. So this can be written as x plus 3 equals 8. In order to solve this, we need to figure out what weight the x by itself would be equal to. Let's try taking a pound off the left side. Oh. The equation at the top isn't equal anymore. Oh, we broke it! Actually, no, it's not broken. We just made a mistake. If you look at the middle of the scale, the arrow is now pointing slightly to the right, meaning the right side weighs more. We caused the scale to become unbalanced. To fix that, we can take away the same amount we took from the left. So, -1. Now the scale is balanced again, and the equation is back to being equal. If you look at the equation now, you should notice something weird. We started with x plus 3 equals 8, but now it says x plus 2 equals 7. When we took away 1 from both sides of the scale, it also subtracted 1 from each side of the equation. You know the golden rule? The one that goes, do unto others what you want to be done unto you? Well, algebra has a similar thing, which we'll call the golden rule of algebra. Do to one side what you would do to the other. In other words, the only way to keep an equation balanced is by doing the same thing to both sides, such as subtracting 1 from both the left and the right. So now that we know the golden rule, let's start over. We don't want to take the time to subtract 1 pound at a time. That would take too long. Instead, we want to take away as much as possible at the same time. So right now, the x weight has an additional 3 pounds added to it that we don't need. So let's take those off. Ooh, that scale's unbalanced. We forgot the golden rule. Since we took 3 off the left, we also need to take 3 off the right. 1, 2, 3. Now our scale is balanced again, and look at that. The x weighs the same as 5 pounds. X is 5! Let's remove the scale for a second and talk about what happened mathematically. We saw that x had an extra 3 added to it, so we decided to take those off. But whatever we do to one side must be done to the other. So we subtract 3 from the right side as well. So now our equation is x plus 3 minus 3 equals 8 minus 3. On the left, 3 minus 3 is 0. And on the right, 8 minus 3 is 5. Adding 0 doesn't do anything, so we can ignore that. So we get the answer x equals 5. In that example, we showed every single step, but usually that's not necessary. A less tedious version of that problem would look something like this. We subtracted 3 from both sides. Plus 3 and minus 3 are opposites that make 0, so we say they zero out and disappear. On the right, we know that 8 minus 3 is 5, so we finish with x equals 5. Another good skill to have in algebra is checking your answer, making sure that the answer you got makes sense. With equations, that's as easy as replacing the variable in the original equation with the answer and seeing if it works out correctly. For instance, here we found out that x equals 5. So replace the x with 5. 5 plus 3 is 8. The original equation told us it should equal 8, so our answer of x equals 5 makes sense. Our next example is d minus 3 equals 7. This time we're taking weight away from the variable. So if we want to know how much the variable weighs, how can we fix that? By doing the opposite, of course. To undo taking something away, add it back in. If we add 3 to both sides, remembering the golden rule, the -3 and the +3 zero out, leaving us with D on the left side and 10 on the right. D is 10. Don't forget to check your answer. We plug in 10 for D, and 10 minus 3 is 7, which is exactly what we were supposed to get. So 10 is indeed the correct amount for D. Here's our next problem. 6x equals 24. So in other words, there are 6 unknown x weights on the left that perfectly balance with 24 pounds on the right. How in the world can we solve this one? Well, the key here is that we can arrange the 24 pounds into 6 identical stacks, each stack corresponding with an x. So then if we cut the amount of x's to only one column and do the same thing to the other side, a single x corresponds to a single stack of 4 pounds. That's great if we can see the stacks, but what if we can't? The key here is understanding what we just did. We had 6 columns on both sides of the scale, and then we cut it down to only one column. In other words, we divided the amount on both sides by 6. So in a situation like this, if we divide both sides by 6, we get the answer. X equals 4. Mathematically, here's what we just did. We saw that the x was being multiplied by 6, so we did the opposite. That is, we divided by 6. Whatever we do to one side has to happen to the other, so also divide 24 by 6. 6 divided by 6 is 1. So now we only have a single x on the left, and 24 divided by 6 is 4. So a single x is equal to 4. We don't need to worry about the 1 on the x because saying a single x is the same as saying x. In fact, anytime you divide and multiply by the same amount, like these 6's, we say they divide out or cancel. Make sure to check your answer. If we plug in 4 for x, we get 6 times 4, which is 24, like it should be. So 4 is correct. Here's our last example. Y divided by 8 equals 4. Since the variable's weight is being divided to 1/8 of what it should be, we need to fix that by pumping it back up. Cancel out the division by multiplying, and do the same to the right side as well. Remember what we said before, multiplying and dividing by the same amount cancels each other out. So only y is left over on the left. And of course, 4 times 8 is 32. Last thing left to do is check our answer and make sure it works. If we replace the original y with a 32, then 32 divided by 8 does, in fact, give us 4, meaning 32 works for y. Before we finish, let's review some key ideas. First, every operation has an opposite operation that cancels it out. If the equation is adding, then you should subtract to zero it out. Similarly, you use addition to undo subtraction, division to undo multiplication, and multiplication to undo division. Second, remember the golden rule. Anything you do to one side has to happen to the other side also. It's all about keeping the scale balanced until we find out how much the variable weighs. And finally, always plug in your answer to make sure it works. Next time, we'll be solving more complicated equations, so I hope you're ready.